and welcome to this course, and thank you for enrolling and starting your journey towards a career in data. This course is structured into 7 sections. If you're keen to complete all the sections, you can just follow this course along in the order, starting with the SQL section. You will be instructed on how to download and install everything and where you can access the data. But if you only want to create the Power BI dashboards, you can go to the first lecture of the Power BI section to see the instructions on where to start, as you will need to install MySQL Workbench to connect to the datasets. The 2 dashboards that we create using Power BI are in separate sections. So the first is the Netflix dashboard, and the second is the more advanced classic model sales dashboard. If your interest also only lies with the Tableau dashboards, these are independent from the rest of the course, so feel free to jump straight there as well. The Tableau data is in the resources of the first lecture of the section, so nothing else is needed. As always, if you have any questions or you need any assistance, please don't hesitate to reach out. I'm here to help. And thank you, and I wish you the best of luck in your learning journey. Hello everyone. So I just want to quickly cover a feature of Udemy if you are finding that the course is going too fast for you. So there is a playback rate option just on the bottom left of the video. If you feel it's just going too fast, you can slow it down here by dropping it to 0.75 for example. Or if you felt it's going too slow, you can speed it up to 1.25. You may also be prompted to leave a review from time to time by the Udemy platform, and I really would appreciate any honest feedback here. 5 stars is the highest you can give, and there is an option for 4.5, with the lowest option being 1. If you are giving a review, I do also appreciate any comment and any feedback, with 5 star being the highest and 1 star being the lowest. If you're also coming across an issue, you can find some questions that have been asked in the course in the Q&A option here. You'll see here, there may be an answer as well, so someone else might have asked the same question with some images, for example, that might help. Or if you do have your own question and can't see the answer there, at the bottom you can see there's an option here to ask a new question. And some videos you'll see a resources option. So this will have a link to download a data set that I will prompt you to do in the video. Thank you, and I'll see you in the next video. Hello everyone. So before we actually get started with the technical topics involved in data analysis, I just want to give a quick overview of the different roles involved in the process of collecting, storing, and analyzing data. So the first role is the data engineer. And as you can see from the Venn diagram, the data engineer is responsible for building and maintaining the systems that allow the data to flow smoothly through an organization. So you think of them as architects of the data pipeline. They design the infrastructure that stores and processes huge amounts of data, making sure it's clean, accessible, and usable. So data engineers work closely with both raw data and the tools that transform it. And this enables data scientists and data analysts to do their jobs more effectively. And without the work of a data engineer behind the scenes, it would be much harder to analyze and extract the value from data. The next role is a data scientist, which is really at the heart of data-driven decision-making. They take complex data sets and transform them into actionable insights that can guide business strategy. And this involves a mix of statistical analysis, programming, and machine learning to uncover patterns and trends, as well as relationships in data. But importantly, they build models which help predict outcomes. So whether it's forecasting sales or identifying customer behavior or optimizing business processes, the work often turns raw data into something stakeholders can use to make smarter decisions. And finally, we're going to focus on the data analyst, which is obviously what this course is all about. And data analysts focus on interpreting and presenting data to stakeholders to help drive business decisions. So while we may not dive as deeply into machine learning or advanced modeling as a data scientist would, we still play a crucial role in identifying key trends, generating reports, and helping teams understand what the data is saying. Analysts often work closely with business leaders, translating this complex data into more straightforward and actionable insights. And these visualizations, the charts, and the reports will help companies understand performance and make improvements. So let's look more into the role of a data analyst. So let's look at the process. The first process is data collection. So this course really will focus on SQL databases. And this is the first step, really. We gather the data from this source. There are other ways that data might be collected, such as through APIs, where we actually automatically collect data from third-party apps, or else also surveys and web scraping are publicly available datasets. Okay, and then once this data is collected, the next step would be cleaning the data. This step addresses missing values, outliers, and incorrect data entries, which does happen all the time. And proper cleaning ensures that the data is reliable and ready for analysis. The next step is the exploration of the data. So following cleaning, data exploration will allow analysts to analyze the data using descriptive statistics and visualizations. And this just really helps understand the data and identify trends and patterns. The next step is the actual analysis. So we can apply various techniques such as regression analysis, and then we want to derive insights from this data. This step is where the analytics skills really come into play. Before moving on, then we will visualize the data. And then once this analysis is complete, the visualization really helps to present this findings into charts and graphs and dashboards. Effective visualizations really make this complex data more accessible and understandable, particularly for stakeholders who may not be familiar with this complex data. And then the final step would be to compile insights and recommendations into reports of presentation, or even just a dashboard where the visualizations are held, such as Tableau or Power BI. This step is essential for translating this data into strategic recommendations. So some of the key technical skills that data analysts need to have is, well, the first one is obviously data manipulation and cleaning. So tools such as SQL and Excel, which is what we will focus on, but you could also do this with Python and R, which I don't often use. So manipulating this data is to get it ready for analysis, really, and these tasks is like removing the duplicates, filtering records. We'll learn all about this, reshaping data sets, performing calculations, and feature engineering, which is creating new fields based on other fields. So it is important because you want to clean and organize data before you actually analyze it. So an example of actually reshaping and modeling our data is using SQL to join multiple tables together. So we will be learning all about this during the course. The next step is actually data visualization. So this will be looking at Tableau and Power BI for this, and we will do this in Excel also. But this is where we actually turn this data into meaningful visualizations, where insights and trends can be derived from this. It is very important, and creating a simple bar chart, for example, in Tableau, to compare monthly revenue across regions, instantly just gives you so much insight. You can straight away tell where the best performing regions are. Okay, but before we do start doing all this, we need to query the database and actually get the data. So we will work hands-on, and this will be the first part of this course where we actually learn MySQL. And we're going to learn how to effectively write queries to get the data stored. So most data is stored in databases, and SQL is the most common universal language to query this data. Okay, and then just before we finish this video and get started with SQL, I do want to just talk about some essential non-technical skills that you do need to have as a data analyst. So problem solving is the first one. And the ability to approach data with specific questions in mind is crucial for uncovering insights that address business challenges. Effective problem solving leads to relevant and actionable results. So you can look at an example there. If a company sales have dropped, data analysts might investigate customer purchase patterns, website traffic, and marketing campaigns just to identify the root cause. Next is critical thinking. So strong critical thinking skills are necessary for interpreting data in context. Analysts want to understand the significance of trends and anomalies, as well as the implications of their findings. Then we have the communication skills, which is really important. We need to effectively communicate the findings to both technical and non-technical stakeholders. And this includes creating clear presentations and reports, as well as storytelling, with the data to ensure that insights are conveyed accurately. Then we have attention to detail. So this is really important. Ensuring the accuracy and reliability of the data that's being analyzed. So you want to ensure, that data types are correct, like currency, date, and then our product codes as well, for example. Okay, so while technical skills are important, these non-technical skills do play an equally significant role in a data analyst's success. So in the next video, we will download MySQL Workbench before we actually start working hands-on with it. So please do reach out if you have any questions or issues when installing it.
Workbench. So this is really important to use. So please, let's going to download. Next.
Okay, so now we're going to download MySQL Workbench onto your computer or PC. So I just typed into Google download MySQL Workbench, and it just brings us to this community downloads page. And what we can actually do from here is we'll keep it as Windows and then go to download page. And depending on whenever you watch this video, we will have options of versions, or you can go to the archive. So if you do have any issues with after you download it, you may need to retry it within archives, but you should just try, depending on your computer or PC. You may want to do a little research on the available MySQL Workbench product version for your PC or laptop, but usually I would hope that the latest one will work. So I'm just going to go back and select the latest version, and then just download the MSI installer, first one here, and I'll just click on downloading. It does ask you if you want to sign up or log in, but we can just click on this. No thanks, just start my download here. Okay, and then it is actually just downloading the installer for us, so I'm just going to click onto this once that has happened. And now you can see it's open MySQL installer. So for setup type, we have a few options. We have server only, client only, full, or custom. So I'm going to select custom because we don't want all the products. So for MySQL servers, we'll just click into the latest one. So for me, it's 8.0.33, and then we can click on this arrow just to bring it across to products to be installed. And then if we minimize this, our applications will expand MySQL Workbench, and we'll also get the latest one and bring it across. With the recent update, you might not see the option to download a connector through MySQL installer. So don't actually worry about doing that now if you can't see it. We only need it for the Power BI section, but what you can do after you download and install MySQL Workbench is actually just head straight over to the website. So it's just downloads.mysql.com/archive/cnet. And you'll just be able to download it straight from here. So if we then click on next, these are ready to install, and we can just click on execute. And I'll just pause the video now while I wait on these to install, as it may take a while. Okay, and if the status goes to failed, you might want to just expand the show details just to see what the issue might be. Okay, and the first thing you might want to check is that you have enough storage to actually download MySQL, so you can check your storage and see what's available just in your settings of your Windows computer, and also just ensure you meet the system requirements, the minimum hardware requirements. You can see them here: 2 CPU cores and 2 gigabytes of RAM, and this IO subsystem. So the recommended hardware requirements are here as well, so you can see these in the MySQL documentation on the website, and it also just shows you the required disk space here for whether or not you're using Windows, Linux, or Mac. And if you do, unfortunately, continue to have issues, you can just pop over to Stack Overflow or Google some questions and see what others have done to be able to install it, because every computer and PC is different, and it will depend. So, there are some good answers here for people who have asked the questions to see what the issue might actually be. Okay, and if you can't find a solution, please just ask me in the Q&A. But hopefully you have ended up with a screen like this where we're actually ready to configure the product. So we can just click on next, and we'll keep config type as development computer, and you can leave everything else the same. So I'm going to keep picking my open Windows firewall ports for network access stick. So let's just click next. It does recommend strong password for authentication, so we'll just click on next, and you can enter any password you can, and we'll use this here so just remember. I would recommend starting the MySQL server as system startup. Yeah, I'm going to grant full access, and then we can execute this. Yeah, I'll just pause the video here, this may take a while. Okay, so now everything's done, just click on finish. Next. So I'll want to start MySQL Workbench. Okay, so I already have a connection set up, and I can enter it by just right-clicking and open connection. You just need to type in the password that we just created. Okay, but if you don't have a connection, just in your home, add a connection. You'll see the plus icon beside MySQL connections, and here you can just give it a name. So for example, we'll be using the classic models, and then you can see if everything else has it. I can click on test connection. You just need to enter the password again, and then you can see if it's successful. And then we'll see it. If you do have any issues testing your connections here, you might want to just ensure your server is running. If you've restarted your computer and your server won't start automatically, you might just need to open up your services in your system, actually, not by searching for it, and then scrolling down to your SQL server and just ensuring that it's actually running. And if it's not, you may just need to and start the server. Okay, and then that would help. Okay, Okay, so now we have MySQL Workbench installed. In the next video, we will just have a quick overview of how to navigate through this, and then we will start to actually write queries inside. So I'll see you in the next video. Hi everyone. So in this video, we're going to download MySQL and MySQL Workbench for Mac. So if you go to mysql.com on either Google Chrome or Safari, you can just go to Downloads, and then if we scroll to the bottom here, you'll see there's an option that says MySQL Community Downloads. So we can just click into this, and then what we want to download is MySQL Community Server, which you can see here. So I'll just click into this. So you'll notice that we can only see Mac OS 13. And if you wanted to download an older version, you'll need to go to the archives. Yeah, whenever we select OS version, you can only see Mac OS 13 here. But what we can do here is if you scroll up to the top, and then to the right of general availability, you'll see archives. So we'll just click into this, and then on the product version, you'll see there are many options. So what you'll need to do is just find the product version that will work for your version of Mac. So for me, it is 8.0.1. So I'm compatible with ICR. This is my version of Mac. So I'm download the DMG archive. Okay, so we've just downloaded that, and you'll see now that we can just double click the package once it's downloaded. We'll need to click on continue to allow it to install. So you can read these online resources if you like. We have 3 links here, but I'm just going to go ahead and click on continue. And then we have our license, so you can read through. So we need to agree to it. You can change the installation if you like, but I'm just going to go ahead and click on install. And here you'll need to install the password that you use to log into your Mac, and then click on install software. Okay, so now it's just installing. And from here, we'll just need to create a password to log into MySQL. So if you just click next, and then you can enter a password. And we'll need to remember this because you'll need to use it whenever we log into MySQL Workbench. And I would leave tick to start MySQL server, and then we can just click on finish. And again, we're just going to enter our password that we use to log into our Mac. Okay, so now that's all downloaded, we can just close out this, and then I'm just going to keep this. And then what we need to do is go back to our Chrome, and then if you hit back, we want to now download MySQL Workbench. So again, you're going to need to select the product version that you selected for MySQL. So for me, it's 8.0.18, and then we'll just click on download. And then once you've downloaded and opened it, you'll see a page like this. So we need to copy MySQL Workbench across to applications. So you just drag and drop it in. Okay, so now we're done with the installation. Now what you want to do is just press Command and Space, and then we want to search the MySQL Workbench, and then we'll just double click, and then you can open this, and you should see something like this. So if you don't have a local instance here already, I'll just show you how to add a new connection. So we just click the plus icon here, and then all we need to do is give the connection name. So I'm just going to name this Classic Models because that's the name of the schema that we will be using in this course. And then all we also need to do is click on Store in Keychain. You'll see the same password. So if we click on this, you just need to enter the password you created whenever we set this up, and then we can click on OK, and then that's it. So we can click Test Connection, and you can see it's been successful. So now I'll just click on OK, and OK again, and now you can see the connection. Okay, so this is just an introductory video to MySQL Workbench, and we're just going to show you how you can navigate through the program. So we have our connection here, and as I mentioned, you can add a new connection by just clicking on this plus button if you want, and you can give it a name, and then we can just test the connections. Okay, but we do already have this Classic Models connection, so what I'm going to do is double click into it, and you won't see any schemas here, you'll only see this. We'll have administration and schemas. If you can't actually see the schemas, you just need to click on this schemas button here, and you won't see Netflix or Classic Models, but don't worry, we are going to install them or import them. Okay, but whenever you do have tables, we can view them by right-clicking and selecting the rows. So we will do that a few times, but we will also learn these select tables, don't worry. Okay, and then from here we can also open a new query by clicking on this button here, and then we'll, as you can see, open the query. And then whenever we do have a query, we can execute it. So I'll just write a quick query. As I said, don't worry, we will learn all this. But we can either highlight and click this lightning bolt to execute, or we can just click anywhere inside the query and click on execute. And as a shortcut, you can hold Control or Command and hit Enter, and it will also run the query for you. And I do often copy and paste by highlighting Control and C, and then Control and V to paste. I do often do this. Okay, and then inside our tables here, as I mentioned, we can right click them to select the rows, and we can alter the tables. We're going to do all this. We're going to change column names, update them. You might also want to save a query, so you can do that. You can just click on File and Save Script As, and then save the script somewhere in your documents, which you can then reopen. But whenever you actually close out of MySQL Workbench, you will find that whenever you reopen the connection, it will have saved queries and it will open where you left off. Okay, I will mention this throughout the course also, but we have this Don't Limit drop down here. Hopefully yours says Don't Limit, but if it doesn't say this, do change it to say Don't Limit. Otherwise, our output will be limited. Okay, so I'm just going to make sure that says Don't Limit. Okay, we do have the option of only executing statements under the keyboard cursor, but I will often just use execute, and you will find that I will just use shortcuts also. Okay, and one other important thing is that if we do have multiple schemas here, multiple databases, and we will have two, you need to ensure we double click the one that we'll be using, and it will go bold whenever we actually double click it. Okay, so if we double click into Classic Models here, and there is no table called task, and we try to run this, it's going to produce an error. So errors you may need to drag up to actually see the action output, which will tell us what an error is. And the reason this has to run is because Netflix has not been selected. And we can't force the tables to come from a schema. If we specify the schema first with a dot, then run it. So this will still return the output, even though this schema has not been selected. But it is often just easier to ensure it's selected by clicking onto it. Okay, so we will start to import our data soon, but in the next video we will just understand a bit more about SQL. Hello everyone. So before we actually get started writing our SQL queries, I just want to cover a bit of basics on what SQL is, or structured query language. So what is SQL? Well, it's a powerful programming language, and it's used to manage and manipulate our relational databases. It is the standard language used when interacting with databases, and it's widely used across industries by data analysts, data administrators, and even software developers. And then it also just allows us to perform various operations such as querying our data, updating records, or manipulating records. We can insert new data, and we can also delete data from databases using SQL. And then finally, it's essential for data analysis. It enables us to extract valuable insights from large data sets and perform manipulation and generate reports which help managers and decision makers make their decisions. Okay, and there are different types of SQL language, and depending on your role, you may use one or more of these. So the first one is data definition language, or DDL for short, and it's used to define and manage the structure of the databases, typically used by database administrators. The commands are things such as create table, alter table, drop table, so we will look into this briefly. And as I mentioned, it's used by database administrators to design and modify database schemas. Data manipulation language, so it's used to manipulate data stored across the database, and commands such as select, from, insert into, and update tables are examples of data manipulation language. So this is what we'll cover mostly in this course. It's used by data analysts and app developers to retrieve data, modify, and manage the data. And then the final one is data control language. So we won't really touch on this, of course, but it's used to control access to data within databases. So database administrators would typically grant or revoke access to workers, and they use this using the data control language. Okay, so let's first just look at the three main commands used in data definition language by data analysts. So the first one will be create table, which is used to just create a new table in the database. Then we have the alter command, which is used to modify the structure of database objects, and it also can be used to add columns. And then we have the drop command, which is used to delete existing database objects, such as tables. So here's an example of how our create table command would look. We have create table, and then we have our table name that we want to create. And then inside brackets, we just insert the name of the columns that we want to create, followed by the data type of that column. So we can add as many as we want here. The alter command, very similar. It's just alter table, table name. Then if we want to add a column, we just use add column after that, and then we insert the column name and data type. And then the drop table is just simply a drop table, and then it's going to be the name of the table that you want to drop. So let's look at a couple of examples. Alright, so I'm now in my SQL Workbench, and so don't worry if you do see any schemas here or anything that looks different to what you have. We will create these in future videos. But let's just first briefly cover the topics that we were discussing. We'll create a new schema to do that, so we just need to right click anywhere in this white gap under schemas and click create schema. And we just want to learn here, so I'll just call it learning. And then at the bottom here we can just click apply, Okay, so it was just telling me there that because I had a capital L, it's going to create it all as lowercase. And then it actually tells us the script that will be applied. So if we even just copy this and cancel out, so remember it hasn't created our schema yet, but I'll just add one in, and we paste this in, create schema learning. We can run that, and that is executed successfully. And now you can right click and refresh your schemas, and now learning is actually created. So this is how we can create a new schema. So there's two ways, but this is how you can write it out using the DDL, the data definition language. Okay, so we created the schema, and we can separate each query with a semicolon, and then just start writing a new one. So let's do that to create a table, and we can create any table we want. We'll just name it. We'll make one up, and we'll call it customers. Okay, and then in brackets, this is where we can actually add the column names that we want to use. So let's create a column called customer ID, and the data type will be in. And then if we close our brackets and run that, so if we actually hit execute here, it's trying to run both. It's ran the schema as well, which hasn't worked. So we want to highlight this piece of code only and hit execute. Our other option is to open a new query, and just have each query separate. But there's not much in these, so I like to actually just have them all in the same query and just highlight the ones that I'll be running at a time. It's really a personal preference. But because this first one had failed, we got the, it said create schema learning, but then we have this message saying cannot create the database learning because it already exists. It didn't actually create the table, so that is why we have to highlight it after and run that. Okay, but if we click over to learning now, and then we need to right click on it and click refresh all, but you'll notice initially it still hasn't appeared. And this is because I wanted to show this because it's a common mistake. We double clicked into I clicked into a different schema. I'm using Netflix New. And because I ran this piece of code while using this schema, it's created the customers table in this schema instead, our Netflix New. So you can see here we have this customers table with one column, customer ID. There's no data in it. Okay, but this will give us a good opportunity now to drop a table. So if you remember, we can just write drop table, and then all we have to say is customers. Okay, so we highlight this because we're using Netflix New. We can just execute it. This ran successfully, and now we can refresh Netflix New, and our customers table has disappeared. So now we can create a table in learning. So if we double click into learning, it will start using that database. And if we actually run this cell now, it's going to create the customers table in our learning schema. And the first thing I would like to do here is just comment out our drop table customers, just so we don't run it again by accident. So we can comment out by using the same shortcut, control and /, or you can just add two dashes on the space. Okay, so I'll run this, and then refresh learning, and now that table appears in learning. Okay, so we can add multiple columns here. Actually, then I will need to drop the customers table and recreate it again, but let's do that just to get more practice. So we can have, say, customer first name, and that's going to be char or character data type, and then we'll have customer last name, and that's also going to be a char data type. So it's just going to have three columns: customer first name, last name, and the ID that references the customer. Okay, so I will drop this, and then comment it out again. So now it's gone. Then we can create that table, refresh all, and now we have the customer table again. But this time it has the three columns: ID, first name, and last name. And we can even just have a very quick look at it, even though there's no data, by right clicking and hitting select rows. Okay, so it's saying select star from learning.customers. So this learning is not necessary. SQL workbenches generate this query by itself, but that learning part is necessary when this schema is already selected as bold. But it is optional, and it's probably good practice to actually add it in. So learning.customers just says we want to take from the customers table of the learning schema. And here's the output here, and obviously there's no data because we haven't put any data inside it. Okay, but let's just keep the customers table and the learning schema for now, but we will end up deleting this. But in the next video, I'll just show you how we can insert some data into this table. Okay, as I mentioned, let's insert a few customers into this table. So the rules here are that we have to, so this is the syntax: insert, into, and then we have to give the table name, which is customers. We can give the schema name first, let's do that as well. But since, as I mentioned, we have selected the schema, which is not essential. But insert into learning customers, then values. I'll just keep this all caps. It's not essential again, but I want to. And then in brackets, we want to insert the values. And it has to be in order, so we have an ID, first name, and a last name. And because our ID is an integer column, we don't have to put it in a side quotation marks. So I'll just do 101 for the first ID, and then for the first name, let's just do John. And then for the last name, we'll do Joe. I'll just put a comma in between these, and then we just close our brackets. And before we actually hit execute, we don't want to run this query first. We will just highlight our insert into statement, and then click on this lightning bolt for execute. And now we can see actually that we have an error. It's tried to insert in these values, but it's saying that the data is too long for our column first name. And the reason is because we set these columns as just a chart, which only allows one character. So this will give us a chance now to alter the table. And we can do this simply with MySQL Workbench by right-clicking into customers and going to alter table. Okay, and under our data type here, we have our two columns. We can just double-click in. And a better option here would be bar chart. So bar chart, inside brackets, we enter the length, the maximum length that we want this to be. So I'm just going to put 50. I don't believe anyone will have let's just go 75 to be safe. We can do 75 for the first and last name. Okay, and then that will change both these data types so that we can fit more characters inside it. So if we click on apply, it actually gives us again the SQL script to be applied to the database, which is alter the table, customers, change column. So it's actually just changing the data type here. Okay, I'll click on apply, and now it's been successfully applied to the database. You can see on the left hand side here, our bar chart 75 is showing up under both our column types. So we can just close out of this, and now if we run our statement, it's been executed successfully. So we've only inserted one value. But going back up to our select start customers, we can highlight. Now if we hit execute, we get one record. Okay, John Doe, our only customer. But let's add in a few more just for some practice. Now we don't want to run this again, so I'm just going to comment it out. Let's copy and paste it below. And remove our comment. Okay, and let's add in 102. just add in someone else. Oh, I have caps on. This is something that will happen quite often where you have your caps lock on. Let's just go Sarah Jones. And then we can add multiple just by entering a comma. And then on a new line, I'll add in a different identifier, comma 3, Richard Smith. Okay, so let's just highlight this and run it. We'll execute the statement. And then if we go back up, we can see that it's been run successfully and it actually has a message, 2 rows affected. And now we can select star from our customers. We are going to cover these select statements, don't worry. I just want to bring the output, and we have 3 customers in our diagram. Okay, so the final thing we'll want to do is now drop this table because we're not going to use it. We'll be working with a different database. So to do that, we have a few options again. We can right click this learning, and we have the option to drop the whole schema straight away. But first we'll just drop the table. We don't actually have the option whenever we right click on the table. We need to actually execute a piece of SQL code, which we covered in the last video, and it's just simply drop table, and it'll be customers. Okay, again, we selected our learning schema, so let's just run this. And we'll see the output. It's been executed successfully. We have the screen tick. Now if it's already disappeared, we don't have to refresh. There's no tables anymore. And then finally, we will drop our schema. Learning. Okay, I'll just highlight, execute that, run successfully, and now our learning has disappeared. Okay, so that's really just an introduction to data definition language, so how we can create and schema, create tables, drop tables, and even alter the table if we want to change the column name or the column data type. But in future videos, we will focus more on data manipulation language, which is much more commonly used by analysts. Okay, so now that we have MySQL installed, we can just right click and open our connection that we just created. And you can just save the password if you like this, so you don't have to type it in every time. And then to set up our schema that we'll be using the classic models, I have uploaded this document onto the resources. So quite a long document, but if you just Control A to select everything and copy it all, just with Control C, I'm just going to paste it into a new query. So you can open a new query at the top end. Just click Control C. And then what we can do is we want to run all of this. So again, Control A to select all, and you'll see this line will go to execute. And if we drag up from the bottom, you can see it's all successful. So now we can just right click our schemas and refresh all the funces, and you'll see classic models will show up, and then we have our table. So now we're ready to start querying. Okay, so I'll see you in the next video. A relational database is a collection of tables of data, and these are all linked by a common identifier, or a key. Each table has a primary key, which is a unique key assigned to each row. This key is a connected table to another. It is known as a foreign key in the other table. There are 3 ways 2 tables can be related to one another: one-to-one, one-to-many, or a many-to-many relationship. The best way to show this is with an entity relationship diagram. This diagram shows how each relationship would be displayed visually with 3 tables: building, room, and class. The many sides of the relationship looks like a crow's foot, which is the name of this type of ER diagram. Building code is the primary key for the building table and is connected to the room table. The same applies to room code, which is the primary key for the room table and the foreign key for the class table. That shows this relationship. Let's look at the tables we will be querying in the classic models database. So these are the 8 tables of the classic models database. And you can see in the middle customers and products, and then you can see order details and orders. So we'll use these 4 tables quite commonly, but we will use the other ones as well. But if you look at customers, for example, like orders, you can see the relationship is a one-to-many, and the customer can have many orders. And then these can be joined on the customer number. You can see the customer number is the primary key in the customer table, and then it's foreign key in the order table. Orders and order details, however, are one-to-one. They can be joined on order number. Order details just breaks down the order by product. So when I open up MySQL Workbench, you can see the tables on the left-hand side. You just need to expand the tables. And these are the 8 tables that we use in this part of the course. And if we click on any table, you can see on the bottom left, it shows the columns in the table. So customer number, for example, tells us that this is a key payment to bank, and then data type. So tables shows the time quite quickly. You can do this right here. You can also expand the table. So I have attached that entity relationship diagram to this lecture if you wanted to download it and view it. It may come in useful there, particularly whenever we're doing it. And whenever you go to do the exercises, for example, you may need to find a column. You don't know which table it is. This diagram will help you find that. Just going back to our example here, you have to remember that a building can have many units. Each unit can have many. Just apply this relationship. So we don't want to many units. And if you look at our example, classic models, ER diagram, we have to imagine that each employee will have many customers. Each customer will only have one employee. Or a sales rep. So in the next video, we'll start looking at some basic SQL select statements and we'll start writing the MySQL workbench. I'll see you in the next video. Hello everyone. So before we actually start coding with SQL, I just wanted to show you this project that is available in the appendix. Now it's an optional project, but you can start on it now. It's at the end of the course if you want to further understand relational databases. So it's a project that will start with a raw data set, a Netflix data set, So as you can see here, it's a data set with just one sheet here, Netflix titles, and it has multiple columns. But what we're going to do is actually apply normalization techniques and make it a relational database by creating multiple tables, as you can see here. And then we can end by visualizing this in an ER diagram that we will actually draw ourselves. And we will create our own primary keys and foreign keys. So as I said, it's not essential, and you can just continue on with the SQL part. But if you just want to understand relational databases further, it is worth doing this project. And you can just do it at the end of the course also if you prefer. Hi, so welcome back everyone. So in this video, we're going to look at the selection. So every query in SQL needs a select and a drop statement. Select is used to say which column you want to display. Each column here must be separated by a comma. The name of the table you want to query is then entered after the from. After this, we can add where to show any conditions we might want to apply. This can be, for example, where the name equals John. We can add multiple conditions by separating them with arrows. If you want to show every column from a table, you can use a star instead of entering every column. If you want to show data where only one of two or more conditions must be met, you can use or after the red. We also might want to show data where something is not equal to a value. For example, sales not equal to 0. We can do this by entering either of these operators. Let's take a look at some examples. So the first query here will show all customers whose last name is not equal to Young. You'll also notice that I have to put Young inside the question mark because it's a string. Contact last name is a string data type. So let's have a look at this in my SQL workbench. Okay, so I'm just inside my SQL workbench here. The first thing I'll do is I double click the classic model so that it's full. That means that whenever we're writing queries, we don't have to tell the query which schema we want to query from. It already knows that we'll be classic model. So I'm just going to open a new query here. So plus SQL here. And what I'll do is just start writing select star, and we'll just show everything from the customer's table first. You can see the third column here is called contact last name. And if we order this, we click on the column name in order, click it again in descending order, we have three people whose surname is Young. So we can update these people by just adding in our where statement. So I'll just do where contact last name is not equal to Young, and we need to put Young in single quotation marks. And it needs to be the same case sensitivity as we see in displayed in the data, so you can see it's capital Y. And for not equal to, I will use the left arrow, and we just hit control and enter. and it will run that query for us, and now we can see there's anyone called John. Okay, so the second query here shows the 6 columns. Customer name, first name, last name, phone, city, and country from the customers table, where the country is equal to the USA and the first name is Julie. And the second query shows the first and last name for customers from either Norway or Sweden. Okay, so let's start our whole query here, and you can open a new query if you like, but what I often do is just put a semicolon after the first query, and then you can start writing another query. So I'll just start typing in the 6 columns that we wanted to display, but if we actually write from our table name first, once we start to type the columns that we want to display, you can see a drop down that shows the column name. So it's probably better to write from our table name first. So we just want the contact last name, phone, city, and country. So let's just run this like this. So we can see here country USA is there, so we'll just add that in our where country equals open quotation USA. And the first name, the contact first name, is equal to Julie. Close quotation. So I'll just run that, and you can see there's 4 results here. 4 people named Julie from the USA. So I'll just put another semicolon, and then we can start onto that second query. So we want to show the first and last name. I'll just copy the query from above actually, because we're using the same table, and I can just delete the columns that we don't want to display. So we only want to show the first name and last name. And we only want to see this where the country is equal to Norway, or, so we need to write the country name again. So you can't just write where country equals Norway or Sweden. So we just write where country equals Norway or country equals Sweden, and then we can see the 5 results here. So you can see, if we did just try and show, let's just show the city and the country as well. So we can just see where each person's from. So we can see it's Norway and Sweden. But if we did try and just do it where country equals Norway or Sweden, and we try to run this, you can see it only returns the results for Norway. And in some databases it would actually return an error here, because that's an error code. We need to actually add in country equals Sweden as well. Okay, so in the next video, I'll ask you to try 2 questions on your own. I'll see you then. Hi everyone, so in this video we'll just get you to try these 2 questions on your own. So they're pretty straightforward. The first one is just to show all columns for customers from the USA with surname Brown. And for the second one, you use the employees table to show all employees who are sales reps, display their email address. If you want to make the first one a little more difficult, show all columns for customers from the USA or the UK with surname Brown. Okay, so I'll pause the video now and then I'll give you the answers now. Good luck. Okay, so I've just opened up my SQL workbench and I'm just going to open up a new query here. So we want to see all customers from the USA who are named Brown, surname Brown. So let's first just do a select star from customers table. I'll just execute that one. So from the USA, yeah, you can just see it's not United States or anything, it just says USA. So we want to show where country equals USA, and USA is in single quotation marks. And then we add and contact last name equals Brown. Okay. You can see the results here. William and Julie Brown. And as I said, you can try to make it more difficult to show them from the UK also. So we could add it over country equals UK. And that will execute okay. But you can see it's not just showing the last name being Brown. So what we need to do is put our country where or statement inside brackets. So just before the first country, after the last country, we put this inside brackets. It's going to treat this separately, this condition, and then it's going to check if their last name is Brown. So if we run that, you can see now we have 3 results. One of them are from the UK. So for the next question, we want to show the email address of all employees who are sales reps. So let's just put a semicolon, and let's just do a select star from the employees table, just to see the data inside it. So you can see here there's a job title column, just the very last one, and it also has the option sales rep. So that's what we want to do. Add in a where statement, where the job title equals open quotation mark, and as I said, it just has to be in the same case sensitivity as I put in the data, so capital S and a capital R. Sales rep. And we only want to see the email address. Well, I can just display everything here first, and then just to make sure, yep, we know they're all sales reps. So let's just show the email. So there's the list of emails. Well done if you cut those. So in the next section, we'll look into upper and lower. I'll see you there. So in this video, we're going to look at upper and lower. So often some data will be a mix of uppercase and lowercase characters. For example, the first name might have been entered with a capital first letter, and other times it may not. This would make searching them difficult, which is why upper and lower would be used. I often use this in a where condition. To do this, we put lower or upper in front of the column name, which is inside brackets. Look at the first example. We will create everyone whose first name is Leslie, but since we have added lower to the condition, we must make every letter inside the quotation marks in lowercase. This will return everyone called Leslie, regardless of how it is displayed in the data. In the second example, we will return all employees with the email address matching D Murphy at classicmodelcars.com. And again, it will display the results no matter what case the email characters are entered in the database. Before we actually do some practical work here in MySQL Workbench, I want to point out that this particular version is not actually case sensitive. This is MySQL Workbench. However, if you're working with other versions of SQL, such as PostgreSQL or SQL Server, SQL Server Management Studio, they are case sensitive, so it is important to understand this topic. Okay, so I've just opened up MySQL Workbench. We can open a new query and have a look at some examples. So first, we'll just do a select star from employees. See here all the employees' last name, first name, email address, etc. So if we want to show the Leslie's, as you can see, regardless of what case the characters are entered in the data, we just add in a where, and you can use lower or upper, whichever you prefer. And we do first name equals Leslie. And then if we run that, it's still going to return both Leslies, even though the first letter is capital L. Again, let's just add in a upper, and we'll just show the email. I'm going to just paste in the email that I showed in the example in the PowerPoint. So we can show that in uppercase. Execute that, and I'm just going to show teamwork, even though it is in lowercase. And I will just show you one keyboard shortcut here, over here. So I'll just delete this where statement now. So say we wanted to add in where the email equals, let's look at the second one, sorry, open quotation marks, Patterson, at bars.com. Those locations. And if we want to put upper in front of this, we can change this all to uppercase by holding down Control and Shift and then U for upper in our keyboards, and then we'll convert all of this to uppercase. And we can run that, and it's going to just display mirror patterns. So what we could also do is use upper, for example, in the select statement. So I'll just delete this where statement. Let's select all, and then we'll add a new column called upper first name. And that's just going to be the first name in uppercase. So we can name any column that we create by just adding an as. So we'll just name this column uppercase name. And we'll execute that. You can see all the names are in uppercase. So that is it for upper and lower. And in the next video we will use this along with in and not in. So we'll see you in the next video. So in this video we're going to look at in and not in. In is a very useful operator, and saves you having to write and multiple times in the where clause. If we are given a list of emails, for example, and want to show all customers or employees in that list, it would be easier to use the in operator and put the emails in brackets, with each one separated with a comma. Not in will do the opposite, and it will show all emails which aren't in the 3 emails which we are provided with here, for example. You'll also notice I use the upper operator here as well, since we want to ensure we are matching the condition regardless of the character keys. So let's have a look at this in my SQL workbench. So I'm just going to delete our previous query, and now we can just show everything from the employees table. So I'll just do a select start from employees. You can see here now we have all our employees' email addresses. So let's say we were given a list and we only want to show 3. We can just add in where condition. Where email. Actually, I'll just do upper email. In. And then again, we just open our bracket, put in our 3 email addresses. So I'm just going to paste in the 3 that I had from our slide. So click on these brackets and then you'll see where the other bracket starts. And we can also minimize this. But now these need to be in quotation marks. I don't think it's just pasted it properly, so I'll just put these in proper quotations. You see the color change whenever it's in quotation marks to represent a string. So now upper email is in the 3 and they're all in uppercase. So if we run that, we're only going to see the 3 employees with these 3 emails. And if we just simply change this to not in, it's going to show all the other emails apart from these 3. So it's just very useful if we want to add a filter. So, we want to not to show these 3 emails. We can't just use this operator like we used to when there's only one condition, because it won't work. You can see it returns an error here. So yeah, it says upper and should only contain 1 column. So this is why we have to use not. Now you can see it's run okay. Would be the same if I remove this, for example. Not equal to first email address, and then we'll have to write and then we just have to paste this 3 times. But it's not ideal. It's much better to use not in if you know the query is much smaller. So you can see the benefit of not in. Okay, so that's it for in and not in for now. And in the next video we will look at distinct, like, and order by.
No, yo no quiero programar.
distinct, like, and order by. And you can see here an example of the type of query you will be able to write after this video tutorial. So let's look at distinct first. So distinct is used before a column name in the select statement to provide a uniqueness. I often use this on an individual column when I haven't used a table before to see what it contains. For this example, I want to show distinct countries from our customers table. So I can see a unique list of countries that our customers are from. So let's just run that query in my SQL workbench. I want to see distinct. First I'll just write the table name. I want to see distinct country. You can see here the list of distinct countries now. Yeah, we have quite a few here. But it just shows which countries our customers are from. So another very useful function is like, and it is used when you want to find any record which matches a specified pattern in a column. Percent is the wildcard used in MySQL and represents 0, 1, or multiple characters. In the example here, you can see in our first one that it will show any city which contains new. So the percent before and after new shows that it can be anywhere within the string. So this query would return cities which have been, in the second example, will contain any email address which has classic model in the name. So remember also that this could be used with upper or lower operators to ensure we capture a record with any mix of character cases. So back in my SQL workbench, I'm just going to remove the distinct country here, just replace it with a star to show all our columns. So let's just show any city which contains new. So we'll just add in a where city like open quotation marks and then a percent. I'm going to put new with a capital N. But this isn't how I would normally write this. I would prefer to use upper or lower, especially if it's a large data set. But we'll just do this for now. So yeah, you can see each city contains new. And new given is displayed twice. We haven't displayed distinct list here. Well, even if we did display a distinct list, it would show new given twice because we're showing other columns. But we could just show this as a distinct. And we only want to display city. Then we'll only display the distinct list of cities that contains new. So I'll just control Z that. Bring back all column. And as I said, I would normally use this with upper, or use it with lower. Just change our new to uppercase, and then it will return the same result. But if there was anything in here, which had, for example, not a capital N, but since we were creating with a capital N inside the string, then it wouldn't show up. So the last topic for this video is order by. So the output of any query can be ordered by a specified column in either ascending or descending order. Order by is the last function used in the query, as you can see in this example. The output would return the results ordered by the last name of the employee. SQL will automatically display the results in ascending order, but if you do want it in descending order, you need to add DESC after the column. So let's have a look at this. Okay, so I'll just put semicolon on the start of the query, and let's just bring back everything from the employee table. And what we want to do, now I know we can just get the last name field here and it will automatically order it, but if we wanted to write it in the query itself, add in order by last name, and then the output will automatically come ordered in ascending order. But as I mentioned, you can do it in descending order just by adding DESC after, and then it will be alphabetically descending. And we can add in a second column for this order by statement, so if we just add a comma, say we wanted, for example, you can see Patterson here, there's 3 employees with surname Patterson. So say we want the first name in descending order also, we can show William Patterson first, then we just add the comma and then add the second column. And we'll do this in descending order also. And I'm sure William Patterson is descending order. Okay, so that's it for this video. In the next section, we'll start looking at our joins. We'll see you in the next video. Hello everyone, so I just wanted to add a few examples of and why we may want to use it and that. So I just opened up our task on table and just show all our rows for customers, just select the rows. Let's do the same for employees and the same for workers. Okay, so what we might want to do is we might want to see a distinct list of order date. So all we would do is write this thing. Order date from the order table, and then if we execute that, we're going to get a distinct list. So we can order these in. So they're order by date, order by order date. Okay, there's this one from the first date first. That appears in that first name, very last one. So we know 2005. And this could be helpful just to see what days may be missing. And we could use it to see what days we didn't have any order. So don't forget a distinct list of employees and customers by using joins. And sometimes whenever you start using joins, you may start getting duplicate rows, but they can be filled out with distinct as well, but we'll cover that in the later lecture. Then we can also just get a distinct list of our customers here. This may be requested from someone, maybe there's someone who just started up and he wants it to list every customer that we have. We can get this just from our customers here. And if I go to our orders here, and let's just bring back everything here, just by hitting our select the start, we'll bring back all our orders. So why we might use like, we have our comments here. So maybe we're searching for some word within the comments. We want to see all orders that have the word negotiate in it, for example. And that could mean that someone wants to know, a stakeholder has requested, are there any customers who have negotiated past orders, for example? Well, we can just add it where comments, like, and then that's what we'll add our wildcard. Negotiate. And then it has to be in single quotation marks. Okay, and then you can see here, we have our orders that have comments, which have negotiated. We have renegotiate well. Because we have this percent, the wildcard operator, it's brought in renegotiate also into everything beforehand. It's difficult to negotiate customer, can we renegotiate? So you can just see these orders may have been some difficult customers or could tell us something. So I would like to point out that with most SQL programming languages like PostgreSQL, it is case sensitive. Everything inside the strings, these quotation marks would be case sensitive. So normally you would want to put in an upper or lower comments. Actually in this case, because our negotiation is only being better to see this lower. And in that that would actually mean that it converts everything from its lowercase first, and then it has to contain a lowercase goes here, and then return everything. Okay, but it doesn't seem to work here, because if I convert the string inside this uppercase and search for lowercase, we're not supposed to see the result here, but we still do. So MySQL has figured out that we still want to see it. But it's worth knowing that it is common to use lower and upper with a license. Okay, so I'll see you in the next video. Welcome back, everyone. So this part of the course we will be looking at joins. We will look at how to join 3 or more tables together using a common identifying key, and we will cover these 3 types of joins: inner join, left join, and right join. Looking back at the ER diagram from the start of the course, it makes sense to define which key each table is common to. For the customer and orders table, for example, we have the customer number, so both tables, so we can use this to join these 2 tables together. So looking at inner join first, as you can see in the syntax, inner join comes after the first table name, followed by the name of the table you want to join. After the second table, we specify which column we want to join on by entering table 1's name, a full stop or period character, and the name of the column, an equal symbol, and the same key in table 2. Inner join returns only matching row and will exclude any row which does not satisfy the joining condition. So let's look at an example here. This query joins the customer's table to the orders table. You'll also notice I have named each table T1 and T2. This makes it easier to write and saves us putting the full table name in the on condition, since we can just use this alias. This star will also return all columns from both tables. So let's look at this in MySQL workbench. Okay, I'll open up a new SQL query here. First we'll just select all columns from the orders table. And you can see here, the last column is the customer number. So let's just name our orders table T1. And we'll do an inner join of our customer table. And we'll name it T2. And we just want to join that on T1 dot customer number equals T2 dot customer number. And now you can see we have all columns from both tables. And all columns from the second table will display on the right hand side. So these are all the columns in the customer table. And because we're doing an inner join, not all customers may show up here. So there may be some customers in the customer table who aren't being displayed here because they didn't have an order, as inner join will only return matching rows. So what I can quickly do is I'll just look at this order number 10100, and then let's open up a new SQL query, and we'll do a select star from orders, where the order number equals 10100. Okay, so we have this one order, but we only have the customer number of 363. So in a separate query, we'll do a select star from the where the customer number equals 363. Add number. Then we can see this is the name of the customer, Dorothy Young, Online Diecast Creations. But because we joined these 2 together, it's all being displayed in one row. You can see Dorothy Young, Diecast, Online Diecast Creations is all in the first row here. Something I would like to add actually is, so we have customer number here twice. It's in both tables. So if we only want customer number 363, we can't just add where customer number equals 363. Because this one has an ambiguous column. It doesn't know which table we're querying customer number from. And you can see the error here. Column customer number in where clause is ambiguous. So we just need to specify which table we want to show that from. So I normally just go with the first table, T1, and then we'll run OK. So I'll just remove that. One note I would like to add actually is, if we remove inner here, and if we just select all from orders join customers, MySQL workbench will automatically do an inner join. It will treat this as an inner join. So in actual fact, the word inner doesn't have to be used, but it is good practice to use it. So that is it for inner join for now. But we will use it much more later in the course and during our analysis. So in the next video, we will look at left and right join. So now we will look at left join. Looking at this diagram, left join returns all records from the first table and only matching records from the second table. If there are no matching records, the columns in the second table will be shown as null in the output. So let's say we want to view all employees in the employees table, and whether they have a customer or not. We would use this type of join, with the employee table being table 1, and the customers table being table 2. So let's have a look at an example. In this query, you can see employees table is table 1, and the customers table is table 2. Let's run this query. Okay, so I'll just open up a new query, and I'm going to paste in the query that you saw on the slide. So we're left joining the customers table to the employees table on the employee number. So it's actually got a different name in the customers table. It's called the sales rep employee number. So it's the sales rep employee who dealt with this customer. So let's just run this. So the first 6 employees you can see had no customers, and this is why null is being displayed. So we are still seeing these employees because we wanted to show all employees, but they don't have any customers. And then we're seeing Leslie Jenkins here and Leslie Thompson, for example, multiple times because they had more than one customer. So let's bring back, most employees had more than one customer. Now let's bring back all our columns. I'll just add a star, and then it's going to bring all columns from both tables. So we can see why the first 6 had no customers. It's because they're not a sales rep. They're sales manager, and then there's a VP for marketing, sales, and president. But all the sales reps seems like they had a customer, at least one customer. And then we can see the customer details now that we've got in all the columns. Okay, so not all of them did. See this one here. Yoshimi Kato, for example, and everything is null, and then there's another one here. So actually a way we could view all the nulls is we could actually add in a where. We can condition, and we'll do a where t2 dot customer number is no. And then that's only going to show employees who didn't have any customers. And again, we may expect the first 6 here to not have any customers, so we do that in a second condition, saying and job title equals sales rep, and it has to be in single quotation marks. Execute that, and it's only going to show the 2. So now if we look at right join, it is the opposite of left join. Now it will show all records in the second table listed, and only matching records in table 1. I would rarely use this type of join, and I use left join much more often. But if we use the same query as we did for left join, and switch the tables, it would return the same output. So in the next video, I will get you to try a couple of questions on your own. So I'll see you there. Hi everyone. So in this video, I just want to go over a bit more of joins and get more practice with them. So I'm going to do another example. Okay, we have the customer table here, and then we click into it. We can see it if you remember the columns are on the bottom. And maybe we wanted to show the customers and also their payments. So in the payments table, we have the customer number as a primary key, and in the customer table, we also have the customer number. So we can match these two and join them based on this. So let's first just look at everything from the customer table. I'll just select those, right-click, select those. Okay, so we have everything. Let's start from customer. I'm just going to bring the semicolon to the bottom. And what we could also do then is look at everything from the payments table. So I'll just select those. I just like to do this first. Okay, and now what I want to say, maybe we want to see customers and their payments. Okay, so we can actually get duplicates if the customer made multiple payments. So let's just name this first table A, and we'll do an inner join, so we'll only show the customers who made payments. So we can inner join the payments table. I'll just copy this, and we'll name that B, and we'll join it on A dot, and then we start CR. Drop down, we know it's customer number equals B dot customer number. Okay, and if we give it a star, actually no, we'll bring back everything. So let's say we just want to do the customer name from the first table. And then we'll just bring back the on the right hand side here. So as you know, the second table shows up on the very right hand side, showing all the columns. So maybe we just want to bring, I'll just add B dot amount and B dot payment date as well. Okay, we'll just bring 3 rows back, and now we can see, so we do have duplicates because they've made multiple payments. You can see here, it's only showing the matching record. So even though there's only one record, for example, for this customer name, in the customer table, we're seeing it 3 times because they made 3 payments. And since it's an inner join, it's only showing matching customers when they made a payment. So if we did want to see all customers, so say we were given the question, show me customers who didn't make any payments yet, we could do that with a left join. This is where left join is very useful. Now it's going to bring everything from the customer table, even if they made 0 payments. Okay, so let's change that to the left join, and then hit exit. Okay, it looks the same here, but if we scroll down to the bottom, you can start to see that sometimes there'll be null in the amount and payment date. This wouldn't have appeared before. Okay, and if we wanted to filter this output, only show instances where this is null. That would answer our question as which customers haven't made any payments yet. You can just add in a where, B dot, and then you can select any field from the B table because they're all populated. Let's just do B dot customer number. So that is null. Okay, now it's only showing instances where the second table customer number is null because they haven't made any payments. I'm only going to see each customer name once in this page because there are no payments. Okay, so I hope that helps to understand inner and left join a bit better. I'll see you in the next video. Hi everyone, so now we're just going to try these 2 questions, and I'll get you to try them on your own. So the first one is to show the customer first name, last name, order date, and status of the order for each order in the order sheet with a matching customer in the customer table. And the second question is to display the first name and last name of all customers, and the order date and order number of their orders, even if the customer made no order. Okay, so I'll pause the video now, and you can try it, and then I'll give you the answer after. Okay, so I just opened up the query here. So we want to see the customer first name and last name, the order date, and the status for all orders with a matching customer. So we'll use inner join here. So let's just first select all the records from the order table. Okay, so you can see status, these checks here. Very much common status, but there's cancelled, disputed, in process, on hold and resolved. So we want to see the contact person name on the table. So we actually join our customers table. So let's just name our order table T1. So we'll do an inner join of customers table from that T2. And we're going to join these on the customer number. So if you did want to double check that, we can always refer to our PR diagram, or you can also just look at the customer table here on the left hand side. You can check customers, you can see the primary key is customer number here. And same for orders, so we'll just go to orders, you can see here. Customer number, also in bold, meaning support key. And our primary key is underlined. So after our T1, we'll start writing our column name, and it will show up customer number equals T2 dot customer number. So I'll just run this first. So this is bringing back all the records. And on the right hand side, you can see all the customer details. So you can see this from our previous lecture. But we only want to see the contact first name, last name, and the order date and the status. So it is also good practice, even if the column isn't ambiguous to both tables. It's still good to just put the alias or the name of the table in front of the column that you're querying from, and it's really just in case anyone else is reading your query in the future, which will happen. So, yep, I just ran 4 columns, and they're showing up now the first name, last name, order date, and status for all our customers. Okay, so now we'll try our second question, which is to display the first name and last name of all customers, and their order details, even if they made no orders. So if we want to see all customers, even if they made no orders, we'll need to use the left join, with the customer table being the first table. Okay, so back in my SQL, I'll just add a semicolon here. So let's do a select star from the customer table first. I just like to look at the customer table before I start writing my query. So we know that we have the customer number because we're joining our order zone. But we'll do the customer table first. That's not as well as our join type. So we'll do a left join of the orders. So I'll just first write T2 after the orders table. So we're going to join them on the customer number. Okay, so let's just do all columns first. So we'll see all their orders. So we're going to see the customer name multiple times because they would have been multiple orders. So contact first name is coming from the first table. And so is the last name. And the order date and order number will come from the second table. So let's add it. Okay, so now we can see the customer details and their order details in the same output. So yeah, you can see there is going to be some customers here who didn't make any orders, and it's just going to show from the orders table because there was so much orders. So we can order this by order date. All that comes up first is all the notes. So these will be all the customers who made no orders. So as I said, if you didn't see any customer who made no order, we can just add in where the T2, pick any customer, primary key. So I normally would pick the order number, for example, is. So if we run that, we're only going to see the customers who made no orders. And you can also add it is not null, and I will only show the customers who made orders. But that's just another way of writing inner join with bringing customers who made orders as well. Okay, so we've answered those two queries now. So you can also save them if you like. So you can just hit file and save script or save script as, and you can just save it wherever you like in your computer. And you can also write, for example, question 1. So you can't just write it like this because it will be an error because it thinks this is a what could be queried, question 1. So if we wanted to just comment this out, you can just do a forward slash and a star. But now commenting out the whole query, but close that in by adding another star and a forward slash again. So it's just going to show question 1 at the start here, and then we'll run this query. And then you can do the same. We'll just copy this down. Just add the question. Now you can see that if you ever just refer back to it. So that is it for joins for now. But as I said, we will work with joins a lot later in the course, particularly during our analysis. So you will get much more practice. So in the next section, we'll start with union and union. So see you there. Okay, so now we're going to look at union and union all. So union is used to combine the results of 2 or more select statements. Both select queries must have the same columns in the output, and these columns must be in the same order. Union will remove duplicate records from a query, while union all would include them. You can see in the syntax here for how union is used when writing a query. Let's look at an example. So we've got the output of 2 queries here, query 1 and query 2. If we wanted to show all the results into a single output of both of these queries, we could union them. The output would depend on whether we use union or union all. As you can see in the bottom right table, all jokes is included twice because we have used union all. Let's look at an example in my SQL workspace. Okay, so I've opened up a new query here. Let's just show all the columns from the customers table. So we do have customer first name, customer last name as well. So say we want to show the customers and the employees names. So let's just show everything from the employees table as well. Put a semicolon between. So employee also has a first name and last name. So the column name is actually different. So we actually have to give them the same name whenever we use it together. So yeah, I'll just put a semicolon. Let's just display the first and last name of both names. So in our customer table, so let's just add the first name first and contact first name again. And let's just name that column first name. And we'll also show the contact last name. And we'll get that last name. And then this is the employees table. Like here, you can see it's just first name and last name. So we can union and then start writing our second query. First name and last name. So now we have a list of all employees and customers in the same bucket. Any employees and customers has the same name, same first and last name. They will only be shown once. But if we wanted to show them twice, we could just change this to default. So we also have distinguished here who's a customer and who's an employee. So we could actually add in a new column. So we'll just start it, open quotation marks, and we'll just name it customer. That's going to be the output every row for this particular column. So we'll just name this column type. And in our second query, so we'll have to name this column the same type, but we'll just have all the output be employee. Name that type. Okay, so now we're going to have a new column called type, which shows whether it's customer or employee. Okay, so you can see here, all the customers towards the bottom will be the employees. So I'll just show you some issues we may run. So let's just run our query from show all columns from the customer table. See city here, for example. So in our first union query, we want to add city from the customer table, and then we try to execute the union query again. It's going to return an error because we aren't returning any city column from the employees table. If we look at our employees table, see there is no city column, so we should actually add this to the employees table unless we created our own. So let's just add a column, and then in quotation marks you can just write unknown. But we have to give it the same name, so we'll just name this column city. And then we try to run this time. Just have to turn on after the last name. So we try to see, it will show the we'll start looking at our aggregate functions. The first one we'll look at is sum. We can use aggregate functions on any column which displays a value. And if you look at the example here, you can see we're showing the sum of the amount from the payments table to show the total payments C for each stage. You'll notice I've also named this column total payments by using as. Otherwise, the column would just be named sum. You also have to group by any column that you're displaying which is not an aggregate function. And group by is added after the from statement. So let's run this short query in MySQL Workbench. Okay, so I've opened up a new query here. So before we add our group by and our sum, let's just have a look at the table. So it's the payments table. If I run that query, you can see there's 4 columns here. There's the payment date, and then there's the amount as well. So I'll just click the payment date column here. So you can see that some dates, such as the 21st here, has 2 payments. So we wanted to sum the amount per date. That's where we use our sum and group by statement. So the first column will display the payment date, comma, and then if we just type sum, open brackets, then we need to enter our column name, which is amount. So we'll just name that as payments. From payments, and then, so again, if we try to run that, you'll see there's an error because we need to group this by the non-aggregate function field that we're displaying, which in this case is payment. You can see the actual error code is that we need to group by. So that's added after from, and the table name is group by payment date. Now if we run it, we're going to have each payment date and the amount that was paid. This is payment payments. Payment total payments. And I'll just run that again, so you can see the column names. So let's order this by the payment date. So we order by after our group by. You can also just write the column number. So in this case it's just 1. And we'll do the same. But it is good to actually write out the column. It's a personal preference. I do sometimes just write numbers, particularly whenever there's a lot of columns. But for now we'll start by just writing the column names. Okay, so the next aggregate function we will look at is round. So we can round the output of any query to a specified number of decimal places. Maybe we want to show it at 0 or 1 decimal place. And our previous query was displaying the output to 2 decimal places. So what we can do is we can round it to 1 decimal place by typing round and then putting our sum amount column inside the brackets with a comma, followed by the desired number of decimal places you want to display it. So in this case we'll do it to 1 decimal place. So we run this on MySQL Workbench. Let's start from here. Okay, we can just click these brackets and see where the open bracket or this closing bracket is. So it's currently at 2 decimal places, but we run this and it will only show it to 1 decimal place. Okay, so the last topic we will look at in this video is having. So having is like a where clause, which is used for aggregate functions like sum. We can put in where total payments is greater than 50,000, for example, because the calculation hasn't happened yet. And we must add it after the group by statement. So for this example, we will only display days which have total payments greater than 50,000. So let's run this. So you can see there are some days here where there were total payments greater than 50,000 and some where they were less than 50,000. So say we wanted to only see the days where it's greater than 50,000. So we can try adding where, which is what we would be used to doing. Where total payments is greater than 50,000. It's going to bring an error. Unknown column. So yeah, it doesn't actually recognize the column name, so even if we have the calculation, invalid use of group function. So let's just change this to having. But as you know, we must use having after our group by statement, but before our order by. Order by always comes last. And now if we run that, you can see it's only showing the days where we had more than payments of more than 50,000. So we'll just see if it recognizes the name we gave to the column in the select statement here. Having total payments greater than 50,000. Yeah, it looks like it's recognized it. Okay? We don't have to use the aggregate function for having statement. We also need to, if we're showing the payment date, it also has to be used in the having statement. So having payment date greater than 50,000. And then that will just remove any date before that. So if I run that, you can see it will be showing dates after that. Okay, so we will continue looking at other aggregate functions in the next video. Hi everyone, so now we're going to look at 4 aggregate functions. Count, max, and average. So let's look at count first. So rather than summing a column, we may want to count how many records there are. This could be used, for example, to count how many sales there are for each day. For this we use count and enter the column, we want to count in brackets. We would want to use a column which is unique to the row here, for sales. So we will use order number. You can see with this example, it's very similar to the sales query in the previous video. So this query would just return how many orders there were in total. But if we wanted to bring it down by product, we could use the order details table and just add in the product code and then count how many orders there were by counting the order number. So we would just have to group by the product code as well. So let's just run this. So I've just opened up a new query, and you can see in the orders table we have the order number, and in the order details table we have the product code. So let's just select count order number from the orders table, and see that. So we see 126. So if we counted the order number from the order details table, we're going to have more than that. So you can see it's 2,996. That's because the order details table breaks it down by product, so you're going to see multiple order number. So we would actually have to just count the distinct order number, and then we should get the same result, 326. So yeah, I'll just display all the details from that table, and then it might make more sense. So So order number, so you can see there's 4 instances of order number 10100 because there's 4 products in that order. So that's why we would have needed to count the same order number from this scheme. And as I said in the slide, you could just add in product code here. And then we would just have to group it by product code. So that's going to show how many times the product code is something like that column. See, it just writes calculation as column name. So that's why it's good to go down these name orders. We'll just change the name of the column. So for max and min, you can use these to show the highest and lowest value. So for example, if we want to see the highest payment, we can show max amount. If we want to show the lowest payment, we'll show min amount here. So we can use these in the same select query. So let's just look at the highest and lowest payments received on the 9th of December. So I've added in a house condition here where the payment rate equals the 9th of December 2003. If we run this, so I'll just go over to the tables here. So we haven't used this table yet. There's the payments table here. And if you look at the columns, you can see there's a amount column. So let's just, I'll just right click this one first. New select rows. So I'll open up a new tab. So I'm just going to do select start from payment. So what we can do then is just show the payment date, the max amount, payment amount, and payment amount. So we don't include customer number here. We do have to include the payment date because we have active boxes after it. So that is approved by payment date. And then we run this. So sometimes it will be the same because it's only done this date. But if we add in our date filter, we can do having the payment date equal to say 9th of December. And then we run this. You can see they're two different amounts. So I'll have a name. So we name is highest and lowest. You'll see the two different values here for this date. So if we want to display the average of something, we use AVG. So this query, for example, will show the average amount of payment that was received each day. So we wouldn't even have to bring in payment date. We need to show average amount and then show the average amount in total. So I'll just modify our previous query and I'll just delete the tab. And I'll change it to the AVG amount. Change the name to the average. So it's going to show daily average. We'll remove the day and then remove the group by as well. So you can see what the average payment was. Okay, so that's it for aggregate functions for now. But in the next video, you'll just try a couple of practice